Investigate the sequence um, open bracket a sub n close bracket defined by the recurrence relation a equals a sub 1 equals 2 a sub n plus 1 equals 1 half open a sub n plus x close for n equals 1, 2, 3. Solution: we begin by computing the first several terms. A sub 1 equals 2, a sub 2 equals 1 half open 2 plus 6 close equals 4, a sub 3 equals 1 half open 4 plus 6 closed equals 5, a sub 4 equals 1 half open 5 plus 6 closed equals 5.5, a sub 5 equals 5.75, a sub 6 equals 5.875, a sub 7 equals 5.9375, a sub 8 equals 5.96875, a sub 9 equals 5.984375. The sidebar says mathematical induction is often used in dealing with recursive sequences. See page 72 for a discussion of the principle of mathematical induction. Returning to the text, these initial terms suggest that the sequence is increasing and the terms are approaching 6. To confirm that the sequence is increasing, we use mathematical induction to show that a sub n plus 1 is greater than a sub n for all n is greater than or equal to 1. This is true for n equals 1 because a sub 2 equals 4 greater than a sub 1. If we assume that it is true for n equals k, then we have a sub k plus 1 is greater than a sub k. So a sub k plus 1 plus 6 is greater than a sub k plus 6, and 1 half open a sub k plus 1 plus 6 closed is greater than 1 half open a sub k plus 6 closed. Thus, a sub k plus 2 is greater than a sub k plus 1. We have deduced that a sub n plus 1 is greater than a sub n is true for n equals k plus 1. Therefore, the inequality is true for all n by induction. Next, we verify that open bracket a sub n close bracket is bounded by showing that a sub n is greater than 6 for all n. Since the sequence is increasing, we already know that it has a lower bound. A sub n is greater than or equal to a sub 1 equals 2 for all n, restating that a sub n is greater than or equal to a sub 1 equals 2 for all n. We know that a sub 1 is less than 6, so the assertion is true for n equals 1. Suppose it is true for n equals k, then a sub k is less than 6. So a sub k plus 1, a sub k plus 6 is less than 12, and 1 half open a sub k plus 6 is less than 1 half open 12 close equals 6. Thus, a sub k plus 1 is less than 6. This shows by mathematical induction that a sub n is less than 6 for all n. Since the sequence open bracket a sub n close bracket is increasing and bounded, theorem 12 guarantees that it has a limit. The theorem doesn't tell us what the value of the limit is, but now that we know L equals the limit as n approaches infinity, a sub n exists, we can use the given recurrence relation to write the limit as n approaches infinity of a sub n plus 1 equals the limit as n approaches infinity of 1 half open a sub n plus 6 close equals 1 half open limit as n approaches infinity of a sub n plus 6 equals 1 half open big L plus 6 closed. Since a sub n approaches L, it follows that a sub n approaches L too, as n approaches infinity. N plus 1 approaches infinity. So we have L equals 1/2 open, L plus 6 closed. Solving this equation for big L, we get big L equals 6 as we predicted. I'll do it.